Hello, and welcome to the open house for the sixth grade Science B course for the summer. So I'm going to be talking about the 12-week program that's starting next week, geared toward sixth graders. So first off, let me introduce myself. My name is Galen Tracy. I'm an educator in a Houston area private school, having taught fifth and sixth grade science for 7 years now. 2 of those years, I served as a lead science teacher and department head. I obtained my bachelor's degree in general science with teaching from Temple University, completing the UTeach program, which was originally developed at the University of Texas in Austin. My teaching style is more inquiry based. I like to personalize instruction for each student to keep things engaging and to make it easy to see the connection to the real world and the usefulness of the knowledge. I'm really big into incorporating different learning styles into the instruction so that visual, auditory, and kinesthetic learners are all accounted for. All right, so first slide here is where does the course fit into the rest of the curriculum and programs offered at Momentum. So this is what is on the science curriculum page for Momentum Learning. You can see some of the other course offerings. There's a Science Bowl course, which feeds into some other higher level courses. I believe the track is similar for sixth graders as far as what they would take next. So if you want more information about the courses offered at Momentum, specifically science, there's a QR code in the bottom right. All right, so the name of the course is Sixth Grade Science B, Earth Science. Now, those of you who had me for Science A, that was more focused on chemistry, whereas this program will be more focused on earth science. So basically, it's all of the topics and standards for sixth graders that weren't covered in the earlier course. So let me read to you the description of the program. So it's 12 weeks, comprehensive exploration of earth science that prepares students for seventh grade. It'll include an overview of Earth's systems, including the geosphere, hydrosphere, atmosphere, and biosphere, where students will utilize virtual experiments, worksheets, and TED-Ed videos to understand their interconnections and impacts on life. So there'll be a little bit of a connection between living systems with the Earth science. So they'll also study weather and climate, look at weather patterns, rocks and minerals. They'll explore plate tectonics and the forces that lead to earthquakes and volcanoes. We'll, of course, cover processes like erosion, weathering, and deposition, as well as their impacts on landscapes and how they're responsible for producing different landforms. So that's a general description. The start date is June 16th. So it's Mondays from 6 o'clock to 7:30 p.m. CST. So one of the things I want to emphasize is although there is a prerequisite, uh, the course is designed in a way where it's welcoming to all sixth graders. So if you weren't able to join the Science A course, the courses themselves are independent, so you'll be able to fit right in. The course is an hour and a half long. So later during this presentation, I'm going to give you a demonstration of what a typical lesson plan might look like, right? So here are the more specific topics that'll be covered. So week 1 and 2, we'll be looking at Earth systems. So the geosphere, hydrosphere, atmosphere, and biosphere. Week 3 and 4 is going to be focused on weather and climate, as well as the factors that influence weather, including temperature, humidity, wind, precipitation, and how climate varies across different regions. Week 5 and 6 is going to be rocks and minerals. Week 7 and 8, plate tectonics. Week 9 and 10, Earth's surface systems. And week 11 and 12 is going to be living things in the biosphere. So that's going to bring it back to biology, which is what some of the previous courses I've taught have been focused on. All right, so this is the basic structure for the Canvas platform, which is it's basically where the teachers put their curriculum for Momentum. So you can see weeks are organized in what are called modules. So I can't speak for all of the other courses, but I can tell you that each of the courses is streamlined and that there is one graded assignment that students complete each week. And that's usually about 30 multiple choice questions. So they'll have a week to work on it before it's due. Now for my course, there'll always be a warm-up video introducing the topic unless it's a review week. I'll talk more about that later. They'll have notes, which is a summary of the main concepts for that week's lesson, and then some kind of application, whether that's a worksheet, an activity, a virtual lab. The other day I was planning the week 2 lab, and I found a website that has real oceanographical data on it. So those that are interested in oceanography, in that lab, you actually learn how to interpret the data on the screen and draw conclusions based on it. So students can see the real science and how that relates to what's discussed in the course. The handouts are going to be something I usually publish at least an hour before the class starts to give you time to print. And that is something I recommend doing. Not just because it makes it easier to follow the lesson, but because it's kind of like a record of everything that was discussed during the course. So if you wanted to go back and review a particular topic, it's a little easier than finding it on the website. So all of the sessions are recorded and will remain accessible for an additional 3 months following the conclusion of the camp. Zoom, like the Zoom call we're on now, is what is used to conduct the class, and Canvas is where all of the handouts are stored. Canvas invite will be sent to students from infrastructure Canvas about 4 to 5 days before the class start date. Homeworks need to be submitted on time and will be automatically graded by Canvas. So that's one of the cool things, is as soon as you complete an assignment, you can see how you did. And those frequently missed questions on the previous week's homework will be discussed during the next class. All right, so contact information. If you want to learn more about what other courses are available, that would be the website. The office phone number is 281-277-9075. And if you needed to ask like a particular question and you wanted to do that by email, this would be the email to use, info@momentumlearning.org. All right, so what I'm going to do now, since I want you to have a real sense of what the course looks like, is I'm going to walk you through a previous lesson from the prior course. So this will be week 11 from the Science A course, just so you can see like the structure of what a typical class day looks like. So in a typical session, I would begin by introducing the topic and having students watch a short video summarizing one of the major concepts from the lesson, like this one. I'm not going to play the whole video, just a little bit so you can kind of see what I'm talking about. Right, so we would watch the video, a couple minutes. Most of them are under 10 minutes long. And then after the video, I have follow-up questions to make sure everyone is paying attention and comprehended. Right, so it's multiple choice questions, just like the homework questions, just to get our brain warmed up and to introduce the topic, right? So there's usually about 5 of those. Right, so we would go through each one. I'd give you think time to decide what your answer is, and then I would call on someone, trying to incorporate calling on a student at least one time during the Zoom session, if not more. Right, so then the next thing we would do after the warm-up video and the warm-up questions is we would go into the notes for that week. Right, so it would be, what is the basic information? What are the most important takeaways? And we would go through it just like a traditional lesson, the note-taking aspect. Right, so let me show you what an example notes looks like. Right, so what I've done with these notes is I've taken the standards, determined what's the most important information for students to know, and then I've put it into a summary form. So I try to make them colorful, include images, highlight the vocab words so they're easier to pull out. And then I would include any relevant equations. Right, so for example, in this lesson, you can see we're given a definition for the word energy and work in the first paragraph, and then an example in the image. Right, so then depending on the topic of the lesson, sometimes equations are involved, and they would be given along with some practice problems to solve. All right, so that's basically what the notes will look like for each week. So then after the lecture part, we would have follow-up questions, usually about 10 multiple choice questions, just to make sure that we're retaining the information and then immediately applying it. Because when we're learning something new, the best way to retain it is to apply what you've learned. So as soon as the information is given, we're immediately using it. Right? So then the next thing that we would do is I would introduce that week's lab. Right, so let's take a look at the week 11 lab as an example here. So I try to find as interesting and interactive virtual labs as possible, and also include variety, so it's not just all worksheets. One of the websites that we used pretty frequently last session was PhET, which does really high quality free math and science simulations. So the lab would tell you step by step what to click, and then you would answer questions. So typically the labs for that week, we spend about 30 to 45 minutes of class time dedicated to the lab, and we would chunk it, right? So I would give you, for example, 5 to 10 minutes to work independently on the first page, and then we would go over the solutions, right? So we'd break it up in that way. Right, so just to show you an example of what one of the simulations look like, I'm going to show you this one. You can get a sense to see how interactive the virtual labs can be. Right, so one of the things I would do as I was introducing the lab is to give you a step-by-step tutorial as to how to use it, what are the different things that we can change within it. So for example, this one here is showing a simple machine, right? We have different sources of power that we can select. We have a different device for transforming the energy. And then we have a different device that we're powering, right? So we can add heat, for example, to this teapot to generate steam, which spins the turbine. and powers the device, right? So the PhET simulations are kind of like this. What I really like about them is they're not super restricted. So if a student has already figured out um, the answers, there's ways to further explore and do your own experiments. Like maybe instead, I wanted to try a different power source, right? The PhET simulations allow you to do that, right? So we would break it up into like 10 to 15-minute segments per page with the goal of finishing all of the pages by the end of the session. So typically, the labs are going to be anywhere from 2 to 4 pages long. Now, something I also like to do, because it's really important with retaining information, is it would be very easy to fall into the trap of, okay, we finished this week's material, and now we're going to move on, right? So every 4 to 5 weeks, there is a review week. So during that time, we would go over practice problems. We'd play science Jeopardy. So it would serve as more of like a formal review. And that way we can ensure that by the end of the 12 weeks, we're remembering what we learned in week 2, for example. Right. So I think that's a really fun part. Consistently, year after year, I've gotten feedback from students that they really enjoy the Science Jeopardy review part and that it's helpful. And then what I usually do is I post the Jeopardy link afterward, and I'll show you an example of what that looks like. So that if students want to go back and review a topic, like maybe um, in the fall, they're going to be taking a chemistry course, so they want to brush up on elements. Um, when I share the link, right, you can go back and play um, the Jeopardy again. Here we go. All right, so I'm going to show you an example one, just so you can see what that looks like. So let's say weather. And these are pre-made Jeopardies, but for my course, I make them from scratch. So I'm just showing you this as an example, right? So I would sort the people in the course into 2 teams. We would have breakout rooms, right? So you get about a minute to discuss each question within the group, and then we go to the buzz-in, right? So then we have a virtual buzzer so you can see who buzzed in first, and then that person would answer the question. Right, so yeah, that's one of the resources I like to use. TED-Ed is another great resource for short but engaging videos. Um, so what I'm going to do now is I'm going to give you a preview of the first lesson, which I've already prepared here in Canva. So let's take a look at what does the course that starts on Monday actually look like. All right, so let's see. All right, so week 1 here. Right, the topic is going to be Earth systems and landforms. So I'll give you a preview of the notes so you can see what you'll be learning about. All right, so we'll go through the basics, like what are the main Earth systems. Um, we'll discuss the various cycles that move matter and energy throughout the Earth systems. All right, you can see this lesson is very vocab heavy. We'll see how the different spheres can interact with each other through examples. And then for the lab, I currently have something planned, so let me pull that up. You can get a preview of the week 1 lab. All right, so this one's a fun one because in the first week's lab, you're going to learn how to read a topographic map. So this will be something you can use anytime you go to like a local or natural or national park. You'll be able to look at the map and understand exactly what these numbers represent, right? You'll be able to visualize what does this look like in real life, right? How is this represented 2D? How is it representing 3D structures, right? So yeah, that'll be the first one. Like I said, the week after that will be focused more on oceanography. All right, so does anyone have any questions that I can answer? All right. Well, I hope to see some of you next week. Um, I hope that was helpful to give you a better sense of what to look forward to in the course. And I will hopefully see y'all on Monday.